In today's video, I'm going to solve this question, which we have to find the equation of the particular solution based on the equation of auxiliary equation given. So one thing to see over here is that we don't know the equation of the differential equation, but just the f of x. That's all we know, but that is sufficient to find the particular solution. Um, if so, all of them can have all the terms in this equation can have their forms. For example, e of x. So by the method of indeterminate coefficients, we just have to write down how many forms can ex or sin x can take. For example, while integrating or differentiating. So all of those stuff needs to be included in the solution. Um, so for example, e of x sin x. E of x cannot take any other form but e of x, no matter what we do with it. But sin x can take the form of sine if differentiated twice or four times or whatever, or cos x if differentiated or integrated odd number of times. And we don't know what the coefficient is going to be, so we just assume it to be a or b. We can also find the coefficients a or b because it's a particular solution. Particular solution have particular coefficients, but we cannot in this particular equation because we do not know the differential equation. Anyways, but we cannot assume, like if we had 2x cube, I cannot just assume the form of the solution to be this, because some of these solution might already be included in the homogeneous equation, because the general solution is particular plus homogeneous. So first we need to know what solutions homogeneous equation already has, exclude those and only give the answers which are required or left out by the homogeneous equation. So we can find the homogeneous equation in here through these roots, which is very easy. So let's start with only the real roots, this, this, and this. So it's a very easy way of depicting real roots is just put everything e raised to power. So 0 is e raised to power 0x. Because it appears two times, its multiplicity is 2, we need it to appear two times. So let's say ax plus b. Going to plus minus 3. Now, someone might get confused if it's a single root or whatever, but there are two different roots. E raised to power 3x. Sorry, there needs to be a coefficient. E raised to power 3x because we don't know what the coefficient is. And there needs to be e raised to power negative 3x. And then going to 4. Again, e raised to power 4x, but its multiplicity is 3. So we need three coefficients to represent this solution. Ex squared, fx, and g. And now coming to the unreal roots. So in here also there's something e raised to power. That's the real part of the root, which is 2x. And the iota, whatever coefficient is with the iota, that comes in between the bracket with cos or sine. But one thing which is important here, the multiplicity of this complex root is also 2. So there would be cos x, sin x, but both of them need two different coefficients. So I will, after g, I will say hx plus I, and then jx plus k. And those are all of the roots provided by the homogeneous equation. Once we have this, now we need to find out what is included in the particular solution. So we will follow the same pattern as we did over here, but we need to keep on excluding the roots this equation has covered. Going to 2x cube, Let's just write the equation here again. 2x cubed minus 1 plus e of x sine x plus e raised to power 4x. Okay, this is our f of x. So looking at 2x cubed, we need to find our f of x from here, which should be which should appear at least somewhere in the homogeneous equation. And I can see x with some coefficient is represented in the homogeneous equation. So let's say f of x is, the small f of x is x, and what remaining is x squared. So let's just represent this as x squared dot f of x, which means x squared comma, multiplied by x, which is f of x. Now we need to know two things from here. One is what is our n, what is our k. N is simply the power of what is left on the x, which is 2. K is multiplicity of this root. So I took this x from here. So what's the multiplicity of this root? It comes from the root 0. And we can see in the equation 0 root comes 2 times. So our k is 2. K is always the multiplicity from where the root is originated. Now, the form of this in our particular solution will be x raised to power and some coefficient a. Let's go on from k, L. So x raised to power n plus k multiplied by f of x, which is x raised to power 2 plus 2, and of x was x. So x raised to power 5. So something like that will be in a homogeneous equation. So let's start typing the homogeneous equation. Lx raised to power 5. Then it will also take x raised to power 4, x raised to power 3 square. So this is where we will stop writing more, because x term is already included in homogeneous equation. So that's it. Then comes the second root, which is minus 1. Even though we already did this, because they are of the same form, we do not need to do anything related to negative 1, but you can try by putting f of x equals x raised to power 0, and your n will be 0, and e will still be 2, and you can try if those roots are already included either here or in the homogeneous equation. Sorry, this was particular equation. Now let's come to e raised to power sine x. So as we can see, there's no root that has e raised to power x. So we can just write the forms raised to power x sine x can take, and we know that's sine x and cos x. So MNOP sine x plus q cos x. That's it. And coming to e4x, that is included over here. So we need to see that e4x can be written as x raised to power 0 times e4x. This is our f of x. So our n over here is 0 and k over here is 3, because the multiplicity of this particular root is 3. So I'll just write q r x raised to power n plus k 0 plus 3 times f of x. So r x cube e4 raised to. So I'll just write this. Now there needs to be some x squared term, but it is already included in the homogeneous equation. So all I need is this term, and a particular solution is done.